My name is Joost from Wijgerd, Chief Architect at eBuddy, and I will try to explain you a little bit about our backend infrastructure and how we do it. So basically a little bit of history on eBuddy. So we first started out in I think 2003. I wasn't there yet, but one of the original founders started out as a basically Amazon via the web. So he made basically he reverse engineered the Amazon protocol. Right. So he basically reverse engineered the Amazon protocol and made a server-side component and basically made a website on top of that. He did that in his spare time while working for some other company, and that suddenly took off because a lot of students and a lot of people at their work had Amazon blocked, right? Because people were putting too much time into it, like they do now on Facebook, I guess. And so it became a huge hit, and that made him decide together with JJ and Onno to build a company around it. And well, that became quite big. And then in 2007 they added J2Me, so a Java mobile application, which also became quite successful. I think it's downloaded more than 150 million times. It's one of the most downloaded J2Me apps ever. I think Facebook has overtook us, but I still think we're in the top 3 or top 5. I'm not totally sure, but basically also we added more chat networks, right? So we had Amazon, then we added Facebook, we added Yahoo, we added Google Talk, AOL, a bunch of others. I think we had in total 8, or we have in total 8 networks, which we all on the server side unify into a single protocol, which we then send to our clients, for which we have web, J2Me, iPhone and Android. So this is our chat product. Basically it's a sort of layer in between the chat networks and the client. Basically a unifying server that unifies all these chat protocols into a single protocol, and we can make a multi-chat client. Now this is obviously pretty interesting, but on the other hand, it's not our own network. So we never stored any contact list, because they were all stored on the chat network's infrastructure. So when we decided to move into what I call the mobile messaging space with our new product, eBuddy XMS, we sort of had to rethink quite some stuff in our architecture, because suddenly we were not the in-between service, but we were the destination service, and we had to start storing all kinds of data like contact list and various other stuff, and we had to start sending messages in between our own servers instead of just being the middleman for the other services. So this led us to design a totally new architecture, which basically consists of a Java-based messaging server, which has which hooks up to a message bus, for which we use Hornet Queue, a JBoss product. And we are using Cassandra as our flexible data store. And for our statistics, we're using we have a Hadoop cluster with Hive on top of it to gather statistics about our sessions, about what we do. And what else do we have? We have a media service for uploading and downloading media files, such as video, images, audio, which also does some transcoding, especially on the video side. If you have to support, so in our XMS product, we actually support almost all mobile platforms, and of course they don't all support the same video formats. So we actually have a transcoding engine basically to transcode all different formats for that the clients expect, which is also for instance downsizing a video from HD format to a small format that can be run on a lower end Android phone, for instance. Basically a view on all of our servers. So basically we started in 2003, so we are not in the cloud. We have our own data centers. Actually, we could also run on the cloud, but probably the OPEX would be the operational cost would be a lot higher than running on our own data center. So what you see here is basically an overview of all our application servers that we have running. We'll try to scroll through it. So that's quite a lot. This doesn't include databases, all that kind of stuff. It's basically the front-end facing servers. You see, they are sort of grouped in clusters. Most of them are actually for our chat product, which is pretty big. We have about I think 9 million daily uniques on it, and about 27 million monthly uniques. And with the difference between our chat and our XMS product is that on our chat product people log in multiple times a day, because it's more IM, right? So instant messaging, which is presence based, so people have to log in, show that they're there. While on our XMS product, which is mobile messaging, presence is more implicit. It's like you're always there because you have push, right? So you don't have to become online to be reached. Yeah, so what you can see here is basically all the people that are online. So I'm not sure how well you can see it, but let me see if I can have a nice view. So what we have here is our push backend cluster. So obviously with the advent of push messaging, which started I think in 2010, I think so, right? With the iPhone. So the iPhone was the first one to have it. So obviously we also integrated it into our product, but that left us with quite a challenge, because we were used to having fairly short sessions, right? So a user logs in, stays online for maybe on the web an hour, and then logs out again. And on our mobile clients, on J2Me, people generally stay online for 20 minutes, right? So they come online, check if there's friends online, chat with them, and then go back offline. But of course, with these push messages, with these push platforms, mobile messaging, you never go offline anymore. You log in, you close the app, but you will expect to get messages. So our chat infrastructure, we had to adjust quite some things, because suddenly we had way longer sessions, and our old architecture was not really geared towards that, right? We were mainly geared to like sessions of an hour, and that's it. So we had to make some changes, and what we built was a component in front we called the push server, which basically logged into our chat server and just kept the session online. So it just pretended to be a phone that was still logged in while the phone was actually off, right? And because of that, the push server could then push any messages to the phone. The phone comes back online, connects to the push server, and it's the same. So it's basically a trick we did to get our old chat architecture into the modern push-based world. So what you see here, and maybe you can zoom in again, I'm not sure if you can see it, but we have here, this is per server, right? Number of users, number of accounts. So remember with our chat product, you can have multiple IM accounts logged in at the same time. And then you have the number of users per account. So here you can quickly see that MSN is still the biggest, but Facebook is nearly as big, which is quite funny, because when I started here, it's a little bit more than 3 years ago, Facebook just basically started and only had like, I don't know, 5,000 total sessions per day, and now they're almost as big as MSN. Yeah, so this is sort of the division per network of currently logged in users. So these are all currently connected users. Of course, on the push, it means that they're not actually connected, but they can be pushed. Right? So any message going to them will be pushed, and then they connect and send a message back. So this is basically a view on all of our servers. This is our web. Originally, like I said, we started out with web, so this is our web cluster, which in the weekend is not very busy, as you can imagine, because it's mainly used from schools and workplaces. We have various staging, various beta things, and
about the countries.
No, we don't like shard on countries or something. I mean, our data centers are all in the valley, basically, because traditionally all the IM networks are also there. So the latency between us and them and the IM network is pretty low. So that's why our data center is there, and not, for instance, in Amsterdam, where we are headquartered. So we don't have like country-specific clusters. We all run it from the States, and it's fast enough. And the problem with the latency between the IM networks was bigger than the latency between the mobile clients or between the web client and of course for the web client we do serve all our content over CDN, right? So it's mainly only the messaging that goes over I think the biggest delay you have is about to the valley is about 180 or 200 milliseconds.
You don't queue messages, do you?
Yeah, we do. Yeah. So especially in what normally on chat, like I said, it was built for always connected clients, right? Who connect, and of course then came push. So then we have to queue messages. So even though we push them, we still queue them on our own server, because pushes are not always reliable. So when the client connects, we still send them all the messages that we've pushed. So it's not like we use the push channel as a exclusive send channel. We just use it to inform the phone, and then we will send the thing. So this leads me to our new architecture, which basically just shows up almost the same here. It's our XMS architecture. So we're basically launched in May last year May, and have been developing it since so we launched in May 2011 and have been developing since August 2010. Basically, what we did in our XMS architecture, we took this notion of the push server and made basically the next generation of that. So basically, an XMS application server is geared towards keeping as much sessions online as possible, but not connected. So it's basically geared towards, like we just discussed, queuing the messages, pushing them out, and doing that for as many clients as possible. What we also did was, for scaling purposes, we made the servers be cluster aware. So every server in a cluster, for instance in the cluster here called XMS, which is our main cluster, they, through a cluster membership protocol, they all know that there's 4 servers in this cluster. And then what we did is we divide the whole cluster up in virtual partitions. So in this case we have 512 partitions, which are then by a consistent hashing scheme divided across the servers. So when we scale out, right, we add a server, or when we fail over, the cluster topology changes, and all servers, after waiting a little period for the cluster to, let's have some grace period for the cluster to become stable, will then, with the consistent hashing, basically hash the partitions to the new server. And by doing this, we can we have basically combined this with a persistent session store. So anything that happens in our sessions, so a message coming in, being queued or being sent out, doesn't really matter. We'll change the session state, and we will flush that to a persistent store, which is actually also in Cassandra on a regular basis. It's like configurable, but I think for now every 5 seconds we flush all changes into Cassandra. The nice thing about Cassandra is that writes are really cheap, and so we can do very a lot of writes. Obviously reads are not so cheap, so that's why we also have in-memory cache on the application servers. So each of these partitions have a cache of sessions, and a session is basically a user, who has the app on his phone. But on the other hand, a session can also be a group. So we actually have modeled groups to also be sessions in the system. So if you send a message to a group, it's basically like sending a message to another user, except that the group actually takes that message and then broadcasts it to all the members in the group. But technically, the group is also a session which uses the same system of persistency. And so when there can be data loss, because obviously we can also set this session store flushing to 0 seconds, but that would generate a lot of extra traffic. So we basically have said, okay, we have the trade-off. We take a couple of seconds of data which we can lose, which I must say almost never happens. But of course, every now and then the server crashes. So, but we are not a bank. So. So basically that's how the messaging service works. So this is basically a sort of a continuation of the work we did for our chat product, and I'm pretty happy how it turned out. It performs really well. It's really resilient to errors, and it basically keeps on functioning. Even when a couple of servers just die, and also all users just get their messages pushed.
Does anyone else use XMS?
What do you mean, third parties?
Yeah.
Well, basically
it's your own technology? Or is it?
Yeah, it's our own technology, but we have set up basically so we use it's basically a services-oriented architecture, and we have a single sign-on service which is OAuth 2 compatible. So we've designed it to be open, but currently we are the only ones using it. But each of our mobile clients, so we have about 8 different mobile platforms that we support. They actually sign up as a different client. So we give out a client ID and a client secret, just like any other OAuth 2 system. So in theory, we could provide this service to third parties. And we are also looking into more ways of plugging also what we call XMS services. It's something we're sort of working on now or thinking about, is to be able to plug in third-party services at the back end also, to make it more of a platform. So the design actually allows for that, but currently we are the only ones using it. But I personally would like to see in the future more people use it, but you never know what happens.